Production Stability, How to Run Your Software with Confidence, here on Programming with Palermo.
You are programming with Palermo. You deliver software. You need to move fast, deliver quality, and run your software with confidence. Stay tuned for timeless solutions, simple methods, and topics that will propel you forward. And now your host, lifelong programmer, author, teacher, coach, Christian, and charismatic speaker, Jeffrey Palermo.
Welcome back to Programming with Palermo. I am your host, Jeffrey Palermo, and today we're going to talk about production stability because everybody wants to have confidence when they're running their software in production. You don't want it to go down. You don't want to get trouble reports. You don't want that feeling in the pit of your stomach that something's going wrong that you don't understand, and now it's your job to fix it. So today, that's what we're going to talk about. Let's get into it. All right. So production stability. We're going to talk about how to run your software with confidence. Now, until a piece of software is used in the real world, really all we have is a hypothesis. And the hypothesis is that it will serve the need that it was designed for. Now, prudent architects, like yourself, set up their teams with the test environments that closely resemble the real world. But they also recognize that a simulation is just a simulation. Now, Toyota has gained a reputation for building cars that last a long time with low maintenance costs. And this doesn't just happen by accident. The natural state of the world is for created things to decay and fall into disrepair. A strategy that's employed by many engineering organizations, including Toyota, is to set up testing that is far more rigorous than normal expected production use. And so we might think of car racing as mere entertainment, but for car manufacturers, it's really testing. The engines and other parts and materials that are used, they're tested in those race cars, and those same things end up in normal cars like a Toyota Camry. And through this, even though a Toyota Camry loses traction, maybe on a road, or is involved in an accident or some other stressful happenstance, it's very likely that the components of the car will not have been stressed in that event as much as they did during previous car races. And also sports coaches know that if a game is more strenuous than practice, then they're likely not going to win many games. So practices are designed intentionally to stress the team more than a game likely will. And that's part of the strategy to employ the team, get their fitness going, and make sure that the team doesn't crack during the game. So this should be a strategy that every architect uses. Now, as we dig into that, let's remember that each software system is going to encounter a different set of stresses. For example, pizza delivery restaurant websites, those encounter a huge spike in usage during major sports events like the Super Bowl. Remote systems, for example, might encounter communication networks that are constantly going offline. And based on the nature of likely stresses for your software, it's prudent to design test suites that simulate these events so that you know how the software will behave when that happens at that time. And then, if you aren't happy with how the software behaved, then you can take steps to change it. Now, remember the order of achievement. We've gone over this in previous episodes. First, we have to achieve quality. For what the software does, we have to eliminate almost all the bugs. And again, refer back to the previous video on quality if you haven't seen it. But only after we have a good level of quality can we then turn our attention to production stability. And then after we've achieved production stability, then we can turn our attention to productivity and really have our team move fast and just blow and go and start delivering at a really, really good clip. And if you've been in software for any length of time, when it comes to production, then you know the gut-wrenching feeling of a production system that goes down and it being your job to fix it. And you probably remember wondering, how did this happen? And how didn't we know that it was possible? Or how is this even possible? That can't happen. Okay. So that's kind of what we're trying to prevent. Businesses are disrupted all the time when software workers, depending on the software, it stops working. They're trying to get their job done, and the software just won't work for what they need it to do. And it doesn't always have to be an outage. If a button stops working, if a particular screen slows down to a crawl while a line of customers is waiting there to be served at a register or kiosk, if a generated report mysteriously isn't there, if it doesn't get delivered on time, if a shipping tracking number can't be found in the system, but you're literally holding the package in your hand, any number of issues fall into the category of production instability. It doesn't just have to be an outage. And what you want is to rely on the production systems to work reliably. This gives you confidence, and we all want to run our software with confidence in production. So, as a way of thinking, we have to accept that we will never be able to predict every issue or every problem. We'll harden our systems over time, but we can control what time means. Over time doesn't have to be a long period of time. The first thing that you want to have your team do is change the process so that every new change, every new piece of software goes to production very early. In fact, the code should move to production almost as soon as it's committed to the source code repository. One of the principles in DevOps is to shift left, shift everything left. We shift testing more forward in the process, and we also need to shift production deployments forward in the process. Once we have code, we should integrate it into the production environment. Code that isn't actually being used in production is still unproven, and the longer it goes unproven, the larger it gets, and the larger the body of assumptions that we have made in all that code. Now, I also recognize that some scenarios don't have access to real production usage just yet, and I'm not going to talk about like code that has to go to outer space, but for the pizza restaurant, the Super Bowl might be months away, so we have to simulate production, that massive usage spike that we know is going to happen on Super Bowl again. You do the best you can.
Programming with Palermo is brought to you by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient, moving fast, delivering quality, and running their software with confidence in Azure. If your team has a project that's too important to be delayed or derailed, ClearMeasure can help while keeping your team in the driver's seat and growing in capability. Click on clearmeasure.com for more information. If you are an architect or .NET engineer aspiring to become an architect, check out clearmeasure.com/careers. Now, back to the show.
And if you haven't read that 2009 book, Continuous Delivery, get a copy. I know it's 13 years old now, but get a copy. And the DevOps Handbook, there's other books that have talked about this as well. But don't worry about the emphasis in that book on continuous just yet. If you aren't in production quickly and aren't automated at all, but focus in on the material that shows you how to automatically promote release candidates of your code from environment to environment, and then build your automated DevOps environment very, very early in the life of a new piece of software. And if you have a piece of software that doesn't have one, stop what you're doing and equip your team with an automated DevOps environment. I advocate for building the DevOps environment before even turning attention to any software features. Consider the environment for your team part of your architecture. It's that important. Okay, now, once you're in production or very close with a high stress, pre-production environment, turn your attention to your own optics. Question is, do you know what the software is doing? Do you know what the users are doing? What stress is the production environment under at the moment? And what types of stresses tend to put production environment in a unstable or unusual state? Do you really know? All right, so this is where logging, tracing, and metrics come in. In the past, these concepts have been disjointed, and over my career, very, very few teams do this consistently well. In my experience, it takes intentional effort, but our industry's actually gotten a little bit mature in this area, so you don't have to pull them together in a custom fashion anymore. These days, open telemetry has really simplified the landscape. If you've never heard of open telemetry, head on over to opentelemetry.io and just give it a read. The core concept is observability. Does the software make it easy for you to observe what is going on? Does the software let us ask questions about the system while it's running or even after it's run? Open telemetry pulls all the concepts together and gives us tools to implement it quickly. Now, ultimately, the primitives that you want to think about here in observability under this umbrella of observability are traces, metrics, and logs. All of these are signals or little bits of data that the software emits while it's running. And we need some place to capture all these signals together, which are called telemetry. And a place, Application Insights is a good place. There's lots of other commercial products that are application performance management systems. APM is an acronym that you'll see. But let's go into these observability primitives one by one. So first is logging. A log is just a timestamped message of some sort, and it's coming from some part of the code about what just happened. And this type of telemetry, it's very old, and it's what everyone is most certainly familiar with if you've been doing software for any period of time. It's built right into .NET with the iLogger of T interface. Now, the problem with logs, why logs isn't enough, is that logs typically lack the context about what's happening around it. So they're only one piece of that observability puzzle. The next primitive is tracing. And most of the tracing these days tends to be distributed tracing, but tracing. A trace records the whole journey of a user request after, for example, a button click. Lots of components of the software system may do lots of things on different servers and different Azure App Service, different containers, different places. And so a trace is the combination and correlation of all the actions that happened because of that button click. And the different piece parts may look a little bit like logs, but pulling them all together with a correlation ID so that you can look at them as a unit is a trace. Okay. All right. So the third primitive in observability is metrics. A metric is just a number. It's a recorded value at some point in time. It's a number. And the power of metrics are not the number, but actually the charts that analyze the change in that particular value over time. Now, one automatic metric that .NET collects for us is CPU utilization. And whether it's on a Windows server, Linux server, the Azure environment, we basically get CPU and a lot of other ones for free. The value of this comes not in knowing, oh, I'm at 64% CPU. No, the value of it is looking at the change in this over time, a line graph, and looking at over the course of an hour, course of a day, course of a week, and correlating it with events that might have happened so that you can say, oh, I'm using more CPU than I wanted, or I need to give this environment more CPU capacity so I don't starve it and then end up with a unstable piece of software. So these are the building blocks. I encourage you to read the docs, add the NuGet package to your software, start sending the telemetry to Azure Application Insights or whatever you choose, and then start thinking about how to enable every operation of your software to emit logs, traces, and metrics, and employ design patterns that make this easier for your team so that it happens more automatically. And once you've achieved observability of your software, then you can take more joy in running those test suites that take your software to its knees, because then you'll have the information necessary to understand why your software became unstable. And then you'll be able to design enhancements that'll enable your team to run the software with confidence. And I hope that helps you achieve production stability so that you and your team can run your software with more confidence in production. It's not rocket science, but it just takes a little bit of concerted effort to make sure that every deployed component of your software has observability, put the building blocks in place, logs, traces, metrics, add your dashboard to whatever APM system you're using to collect all of that telemetry, and then you'll be able to analyze it, and then you'll be able to not only make sense of what's happening in production with your real users, but you'll also be able to design better test suites that simulate production-like stresses and use that telemetry to analyze what's happening with your software while you're running those things. So, hope that helps. Thank you for programming with Palermo, and God bless.
You've been watching Programming with Palermo, your primary place for highly productive programming protocols and practices. Remember, you have what it takes. You can do this. You are a programmer, formed by God Himself and called to this profession for a purpose. You can catch every episode at palermo.network, as well as syndicated locations nationwide. We're so glad you tuned in. Until next time, may God bless you, and thanks for Programming with Palermo. Programming with Palermo has made a special arrangement with Marketplace Chaplains. Besides programming challenges, we all face issues in life where we need some help. If you'd like, you can call a chaplain confidentially. To speak with a gentleman, dial 512-923-8178. Or to speak with a lady, dial 512-619-6950. The show won't know you called, and everything is kept in strict secrecy. This is a free service, available if you or a friend need it.